Okay, so we are going to write a small program that takes a command line argument, which is supposed to be a DNS name, and we will do a DNS lookup of that name to return an IP or more than one IP address. We will be using getaddrinfo for this, and at first we're not going to use a hint, so we will basically not filter any of the things that getaddrinfo will tell us, but we will look at all of it, and then step by step we'll probably use a little bit of filtering with the hint. To actually see what's going on the network, we will use a small tool that's called Tcp Dump, and here's a filter already, a filter expression that Tcp Dump uses to only show the packets that you're interested in given, and that is UDP port 53, which basically means we are only interested in DNS traffic. So the exercise should really get you familiar with the DNS lookup part of a program that is written in C, and we will get familiar with Tcp Dump, which is quite a handy tool to monitor your application's traffic, and while developing a networked application, it's actually quite useful to see what it does in the background. Alright, so our starting point is what we did last time, and you might remember this, and from that we will make a copy . And since we have a new program that we need to compile, we also probably want to look at the makefile. Why don't we do that first? So let us add as a new target for that file. Now this is already good enough, but now every time we only want to produce O2, the executable from o2.c, then we need to actually type in make O2, and that is something we don't want to do. We just want to type in make, and for that we now create a phony target. And a phony target is a target that doesn't really exist, so it's not a file on your hard drive or a directory on your hard drive. It's nothing that really exists. That's why it's called phony. And there's a bunch of targets that are often used, such as all and clean are two very common targets. So clean removes all the outputs that have been created, and all, well, what it does is it create all output that the makefile is supposed to create. So let's first look at all. Now let's add all the targets that we actually want to produce, and that's everything we have so far. It's O1 and O2, and we also can include clean. Which we use to remove our files. All right, so we can test them already. You can just say make, and it will create, it will actually trigger all the first target in there, and we can make clean, and we see that all the outputs have been removed. If we make again, it will create both programs, just as we defined in our phony target called all. All right, so with this makefile, we are ready to go. So the first thing we want to do in our program, we want to check whether it received an input and only one input. So we look at the argument counter. And if it's not 2, which means the name of the program plus one argument, then this is not how we actually call this function. But you might want to give guidance to the user as to how to call this function. And very often you have a special function for that called usage. Let's create such a function. And typically when you call usage, you end the program. All right, let's try if this works. Okay, so you see the program hangs, and that is because in our first program we waited for input, and here we can live without that. All right, so once we made sure that we have a single argument passed, the next thing we want to do is we want to take that argument and do a DNS lookup on that, and that function is called getaddressinfo. Let's first see if we have all the includes that we need. Okay, from last time we have systypes and syssocket, but we don't have netdb at this point in time, so we need to include that. And that should give us getaddressinfo. So let's use it. So you might remember that getaddressinfo returns 0 on success, so we want to catch that return value, and it takes 4 parameters: the node name, it takes also a service name or a port number, and then it takes the hints argument, which at this point we leave as null, and then the 4th parameter really is the list of results. So let's call it that way. And for the 3rd parameter, we just leave null as we said, but for the last one, we really want to supply a place where the getaddressinfo function can put all the results. And that's a addressinfo structure. And we will use a pointer and then dereference that to tell getaddressinfo where to place the beginning of that linked list. All right, so this is our call to getaddressinfo. We really want to make sure that it worked, so we actually need to look at the return value. And there's probably something wrong with the input, so we just print usage again at this point, which exits the program. Let's try whether that actually compiles. No, it doesn't. Oh, I used the same name twice, which you should not do. All right, that looks good. Now let's try whether that actually works. So this should not throw an error, and it doesn't. But let's try an invalid input. That should throw an error, and it does. All right, so this looks good. But there's one more thing that we probably want to do, because if getaddressinfo fails, there's an error string that we can generate to tell the user what actually happened. So let us do that. Okay, so this should give the user a better understanding of why getaddressinfo failed and where the input might have been wrong. So the next thing is, once we actually skip this if, we should be in the clear to actually iterate through the results. And for that, we need a temporary addressinfo structure for the iteration itself. All right, so we first set the results to the temporary address structure, iterate through the list until we hit null, which signifies the end of the list. And in every iteration, we just take the next pointer to continue with the next element of the list. So the first thing we might want to do is just print how often or how many results we actually get. This might actually surprise you. So if we make this, oh, there's something wrong. Okay, if we supply a valid name with this, we should get a bunch of results. And we do. So there's 6 printouts, which means there are 6 results, which is probably surprising if you expect an IPv4 and IPv6 address. So we really need to print out more to actually understand what's going on here. So let's do that. And let's start with the IP address itself. The function here is called getNameInfo, and it does the reverse of getAddressInfo. It can do a reverse DNS query, but we don't want to actually let it query. We just want to let it locally convert a address info structure into a string representation of the IP address inside of that structure. So there are flags for that, but let's first punch out getNameInfo and then look at the flags. So the first parameter is the address, the second one is the length of the address, then a buffer that holds the string. The length of that buffer, then the next thing would be the same for the service, but we don't really want to have a service name here because we're not interested in that that much at least. And then we have flags, so let's give it the address. We don't have a buffer yet, but we need to allocate one, and we can do that here. It's basically a string. And the question is, how big should it be? And we saw that there is a define for this, and that is the max host, which can basically store everything that can come back from getaddressInfo. Again, NameInfo. All right, so we have the buffer, the length of that buffer. No service. And the flag that we want to set is we want to tell getNameInfo that there's already an address structure, but what we are really interested in is not the reverse DNS name for that IP address, but really the numeric host as a string representation only. So getNameInfo doesn't need to go out on the network, does a reverse DNS query. That is not what's needed. It's just a local conversion. And we do this with this flag, NI numeric host. And then it knows. And if it fails, we want to print out what failed. And the getAddressInfo string error function can also be used in getNameInfo. The question is, what should we do when that happens? We could well, exit or print usage again, but in this case I would probably continue because there might be addresses left where this actually works. Okay, I think we're ready to look at the addresses. Oh, okay, I see the problem. That's stupid. All right, so let's try the same thing again, and this should now give us IP addresses. All right, so what we still need to do is to actually print out the IP address. And we can combine that with the address family if we want to. And there we typically only have two variations, IPv4, IPv6. And then the address itself. All right, so let's try to build this. There should be a comma. And run it again. And these are the IP addresses. So as we can see, it's the same IPv4 address 3 times and the same IPv6 address 3 times. Something needs to differ, and that is the next step for us. But before we do that, we probably want to actually look at the packets going out. So we use TCP Dump for this, and we want to sniff on ENP0S3 and UDP port 53 is what we are actually interested in. Let's run our little program again. And we don't see DNS packets. So this is an important lesson actually, because we get it from the local DNS cache. It has been resolved already. Why go out on the network and resolve it again? Because the answer is probably still valid. So let's use a different name for now. Let's see if this goes out. And it does. So we are requesting an A record and we are requesting a quad A record. So we want to have the IPv4 address of www.hs-augsburg.de, and for that same name we want the IPv6 address as well. You can see that we get a C name for that, which is hornet.rz.hs-augsburg.de in both cases. And get name info, if we instruct it to do so, will actually give us those as well, but more about that later. So how do the entries with the same IP address differ is the question. So the next thing we probably print out is the protocol number, and we just print the numerical representation of it. Okay, and then we saw a canonical name, and a canonical name might be interesting as well. So if it exists, of course, let's print it out. Okay, so we are good to go and try it again. And now we see a little more and we see a difference. So for the IPv4 case, there's 3 different protocol numbers. There's 1, 2, and 3. And the same is true for IPv6 We don't see a canonical name, although we saw a canonical name in the DNS resolution. And the reason is we need to instruct getaddressinfo to actually give us that canonical name. So it won't give us the canonical name if we don't specifically tell it to give us that name. We will do this later, but first let's look at all those protocols. So we have 1, 2, 3. This one is probably IPv4, one is probably IPv6. We still have SOCDGRAM from our old program. So let's see where this is defined. And here we go. So SOCStream is 1, SOCDGRAM is 2, so that's the 1 and 2, and SOCRAW is 3. And clearly when you create a client or a server, you have a transport protocol in mind that you actually want to use. You don't use everything. So if you write an HTTP server or a client, you know it's going to be SOCStream, so TCP. So all the other things actually don't make any sense in that result list. So really what we want to use is the hints argument. And I think we should actually do this now. So first we need another structure, an address info structure. And we use it here. And as you know, in C, you first need to explicitly make everything null, and we use memset for that. Okay. But we also said we at least want to set the transfer protocol that we want to use. And well, either one will do. Let's do datagram socket. Okay, so now let's see what it does to our results. Memset is not found. And it's in string.h. And now we actually only get 2 results, and this is what we are interested in. This is what we want to see. The protocol is set because we know which protocol we want to use, but we do not restrict the address family because we want to be address family agnostic. And when you look at the code that we have been using so far, nowhere did we actually use the address family, except in the old code we used from last time. But now that we do it dynamically, we don't need to use that anymore. So we don't need to presume an address family anymore, because now everything we do is address family agnostic. And these 2 results we actually are interested in. We know the protocol, and we get both address families back. You see there's a certain ordering, and it doesn't matter how often you actually run this program, the ordering stays the same. In this particular case, we get the IPv4 address before we get the IPv6 address. We're not going to go into the reasons for this in this video. This is the content of another video, but this is important to know how this ordering actually happens, but we'll get to that. So one thing we still don't see is the canonical name, but we know for hs-augsburg.de there is a canonical name because we saw that in the actual DNS packets. We do need to instruct getaddressinfo to give us that, and there's a flag for that. Let's set that flag. And that's our flag. Just make the program again and run it. And there's something particular about the canonical name as well. We see it now here. Now we see rz.hs-augsburg.de, just as we saw in the DNS packet, but only the first result in the linked list will actually get you the canonical name. It's not copied into every result. It's only going to be given in the first result of getaddressinfo. That is something you need to keep in mind when you're interested in the canonical name. Okay, so you can now go ahead and play with the flags argument a little bit. We will play a little bit more with that later, but we probably want one more because we said port 80 is what we are using, and that is a numeric service name. So we probably want to tell that to get address info. Doesn't change the output, but we now explicitly told get address info that we used a numeric service name. Okay, so there's one thing we actually have forgotten at this point. For this program, it's not a big deal because we just do the DNS lookup, exit the program, and after that everything is freed. But we probably, before we exit, want to call here free address info, and what we give it is the results that we have and don't need anymore. Okay, so I was fat fingered a lot. Looking good. All right, so this is it for the DNS lookup. Play with the hints parameters a little bit. We'll get to them, at least to some of them, a little later.